Hello and welcome. I am your host and speaker, Vinaki, and I am Associate BI Developer at Infometry. Thank you for taking the time to join us today. In today's webinar, I will be talking about Git basics and best practices. This session is organized by Infometry. We are a pure play data analytics company based out of Fremont, California, with our offshore development center in Bangalore, India. We came into inception back in 2010, and since then, we have been offering domain specific analytics solutions for high tech, energy, life sciences, retail, manufacturing, and finance customers. Being a data analytics software services and solution provider, we focus on delivering predictive and prescriptive analytics solutions, cloud data warehouse implementation, data governance, enterprise service bus, microservices based integration solutions, big data, cloud DevOps, Salesforce CRM, and product engineering, etc. Infometry has been an engineering and consulting services partner for companies like Snowflake, Google Cloud, Informatica, MuleSoft, Databricks, Fivetran, AWS, Tableau, Adaptive Insights, Microsoft Azure, and Metleon, etc. Moreover, Infometry has developed 22 plus Informatica cloud connectors and Snowflake native apps with pre-built connectivity to NetSuite, Salesforce, and Marketo, enabling real-time analytics across Snowflake, Google BigQuery, Amazon Redshift, Databricks, and Azure Synapse. We have developed state-of-the-art analytics solution InfoFiscus, which can be hooked to any on-prem or cloud CRM or ERP or planning apps. InfoFiscus is 100% cloud-based pre-built analytics software developed using open architecture. InfoFiscus comes in three different flavors: finance, supply chain, and sales and marketing analytics. We are delighted to announce the launch of next generation InfoFiscus Snowflake native application featuring pre-built connectivity to NetSuite, Salesforce, Marketo, and more. These applications enable seamless integration and real-time analytics. That's our quick introduction, and now let's move to our today's agenda. Introduction to Git version control. Git version control allows individual or teams to collaborate effectively by maintaining a history of changes, preventing data loss, and facilitating the management of different versions of a project. What is version control? The version control is the tool that enables developers to track and manage changes made to the source code, documents, or any type of the files over time. We are going to explore how version control software helps teams collaborate effectively and manage project changes, whether you are using a centralized or distributed version control system. Now let's break it down. The role of version control. Version control software is essential for any project. It tracks every change made to the code in a special type of database, allowing developers to collaborate effectively, which means multiple team members can work on the same project without conflicting with each other. Prevent data loss. You can revert to the earlier versions if something goes wrong, ensuring that no work is ever truly lost. Manage project versions. It helps you to organize different versions of your project, making it easy to handle updates, bug fixes, and feature rollouts. In case of mistakes, developers can go back in time and compare previous versions of the code to identify what went wrong, which minimizes disruption and keeps the project on track. Types of version control. Centralized version control. In a centralized version control system, there is one central server where all team members push their changes and commit their work. This central server acts as a primary source of the truth for the project. How it works. Everyone works on local copies of the project and regularly syncs with the central server to get the latest update or share their progress. Key benefit. This setup ensures that the whole team is always working with most up-to-date version of the project. Distributed version control. In distributed version control system, each developer has complete local copy of the entire project, including its full history stored on their own device. This means developers can work independently and offline without needing constant access to the central repository. Syncing happens when the team member is ready, allowing them to pull update from others or push their changes to an online repository. This decentralized approach gives more flexibility and supports offline work, making it easier for teams to collaborate without always being connected. Both systems serve the same purpose. At the core, both centralized and distributed version control systems perform the same fundamental function. That is, they track and manage changes, making collaboration and version management possible. The main difference lies in how they handle syncing and access to the project history. Centralized systems rely on a single server, while distributed systems allow every developer to work with a full copy of the project, offering more flexibility and offline capabilities. Today, we will dive into some of the key reasons why Git is such a powerful tool for the developers. Let's go over the main features that make Git stand out. Free and open source. Git is completely free to use and open source, which means anyone can access it, use it, and even contribute to its development. Whether you are a solo developer or part of a team, Git is a tool that always available without any cost. Distributed. With Git, every developer has a full copy of the repository on their local machine. This allows you to work independently and even offline without the need to constantly rely on a central server. You can make changes and commit them locally, syncing with others only when you are ready. Branching. One of Git's standout features is branching. It's super easy to create a new branch to experiment with new features or fixes without affecting the main code base. Merging those changes back into the main project is simple too. Git makes managing different development track effortless. Collaboration. Git is built for collaboration. It enables teams to work together smoothly, syncing the changes, reviewing the commit history, and resolving the conflicts efficiently. Whether you are working with one teammate or large group, Git helps keep everyone on the same page. Speed. Git is optimized for speed. It handles operations like committing, checking out branches, and navigating project history very quickly. This ensures a smooth workflow even in large projects without slowing down your development process. Git makes managing and collaborating on projects more efficient, flexible, and fast. If you are not already using it, it's time to get started. Welcome to the Git installation guide for Windows. Let's walk through the installation process step by step. Step 1. Download Git. First head over to gitscm.com and download the latest version of the Git installer for. Step 2. Run the installer. After downloading, run the installer. The installation wizard will guide you through the process. You can choose the default settings which work for most users. But if you want to customize things like your preferred editor or path settings, you can do that too. Step 3. Create a GitHub account. Now we will create a GitHub account to host your repositories. Visit GitHub sign up page. Fill in your email, username and password to get started. Once these steps are done, the Git is installed on your computer and you are all set to start using GitHub for version control and collaboration. Welcome to Git Workflow Overview. Let's dive right in. Clone the repository. If you're starting a project or contributing to an existing one, you will first need to clone the repository to your local machine. This step gives you a full copy of the entire project, including its history. Create a branch. To avoid directly modifying the main project, you will want to create a new branch. This is especially important if you are working on a new feature or bug fix. Branching helps keep your changes separated from the main code base. Make changes. Making changes to your code, you can add new features, fix bugs, or improve existing code all in your isolated branch. Stage changes. Once you are happy with your changes, you need to stage them. This tells Git which changes you want to include in your next commit. Commit changes. After staging, you will commit your changes to the local repository. A commit is like a snapshot of your changes along with a message explaining what you did. Committing frequently allows you to keep track of your progress and provide context for each change. Push changes. Once your commit is ready, it's time to push your changes to the remote repository like GitHub. This updates the central project with your new changes. Now others can see your work and you can collaborate with your team. Create a pull request. After pushing your branch, you will typically want to create a pull request to merge your changes into the main branch, often main or master. This allows your team to review the changes before they become a part of the main project. The pull request is the point at which you review your work and discuss any necessary improvement with your team. Pull latest changes. Before merging your changes, it's always a good idea to pull the latest changes from the remote repository to make sure your branch is up to date. This ensures that your work is synchronized with others' update and avoid merge conflicts. Merge changes. Once the pull request is approved, you will merge your branch into the main code base. This step combines your work with main project. Merging makes your changes officially part of the project and the workflow continues. How to create a new repository on GitHub. Creating a new repository on GitHub is an easy process. Here is a step-by-step guide to help you get started. Step 1. Access your GitHub dashboard. First, make sure you are logged into your GitHub account. On your GitHub dashboard, locate the Repositories tab. This is where you can manage all of your repositories. Click the New button. In the Repositories tab, click on the Create Repository button and this will take you to the page where you can set up your new repository. Alternatively, if you are on any GitHub page, look for the plus icon in the top right corner of the screen and click on it and then select New Repository from the drop-down menu. Step 2. Fill out repository details. You will now be prompted to enter the details of your new repository, that is repository name. Give your repository a meaningful name. In my case, it is repo_test. Description, that is optional. Add a short description of what your repository is about. Visibility. Choose whether you want your repository to be public, which means anyone can see it, or private, only you and the invited collaborators can access it. Initialize this repository with, you can choose to add a README file, which is a recommended option, a .gitignore file if you are working with a specific language or environment, or a license if you want to define how others can use your project. Step 3. Create the repository. Once you have filled in all the necessary information, click the Create Repository button at the bottom. You have just created a new repository on GitHub. You will be directed to your new repository's main page where you can find the clone URL, that is HTTPS or SSH, to link it with your local Git setup. And that's it. You have successfully created a new repository on GitHub. Now you can start pushing your code, collaborating with others, and managing your project all in one place. Today we will cover some essential Git commands that you will use often. These commands help you to interact with your local and remote repositories. Let's start with the git clone command. The git clone command is used to create a copy of remote repository on your local machine. This is typically the first command you will run when you want to contribute to an existing project or start working with a project hosted on platforms like GitHub. So how it works? When you run this command, Git pulls down the entire repository, including all of its history, branches, and files. The repository will be copied to your local machine and you will have fully functioning project ready for you to work on. Now you have cloned repo_test. Next, let's take a look at the git status command, an essential tool that helps you keep track of your working directory. The git status command shows the current status of the files in your working directory. It's like a quick check in that tells you which files have been modified, which files are staged, that is ready to be committed, which files are untracked, new files that Git doesn't know about it. The Git current branch you are working on, how it works. When you run the Git status, Git will provide an output that tells you the files that have been modified but not yet staged, the files that are staged and ready for committing, any files that are untracked or newly added to your directory. Now let's look at another key command, that is git add. This command is used to add changes to the staging area, which is a crucial step before committing your changes. The git add command tells Git to include the changes made to a specific file or files in the next commit. When you modify the files in your project, Git doesn't automatically track them for the next commit. You need to explicitly add them to the staging area. How it works: the git add command prepare the files for the commit step by adding them to the staging area. After running this command, Git will include these files in the next snapshot or the commit you make. You can add individual files or all modified files in one go. Next up, let's cover the git commit command. This is a key part of the Git workflow because it actually saves your changes to the local repository. The git commit command takes all the staged changes and commit them to a local Git repository. The "-m" flag allows you to add a descriptive commit message to explain the changes you have made. How it works: after you stage your changes with git add, you will use git commit to save them in the version history. The commit message should briefly describe what changes were made so you and others can understand the purpose of the commit later on. Now let's go over the git push command. This is the final step for sharing your local changes with others in the remote repository like on GitHub. The git push command uploads your local commit to the remote repository such as GitHub, GitLab, etc., making them available for others to see and work with. You push changes after committing them locally. How it works: the origin is the default name for your remote repository. You can have different remotes if you need. The branch refers to the branch you are working on, usually main or master, but it could be any branch that you have created. This command takes all the commit you have made locally and pushes them to the corresponding remote branch. Next, let's go over the git pull command. This command helps you to stay up to date with changes made by others in the remote repository. The git pull command is used to fetch the latest changes from the remote repository and then merge those changes into your current branch. It's a quick way to ensure that your local copy is synchronized with the remote repository. How it works: when you run git pull, Git does two things: fetches the changes from the remote repository, that is, it grabs the latest commit, files, and branches, merges the fetched changes into your current branch. Then it is important to pull regularly to keep your local repository in sync with the changes made by others. So why it is important? Pulling before you start working ensure that you are always working with the most recent changes, reducing the chances of conflicts later. If there are new changes on the remote that you don't have locally, the git pull will update your local branch with those changes. Now let's dive into the git branch command, which is all about managing branches in your repository. Branching allows you to work on different features, bug fixes, or experiments without affecting the main project. The git branch command is used for listing, creating, or deleting branches in your repository. Branches are a powerful way to isolate changes and features, and the git branch command helps you to manage them. How it works: list the branches. If you run git branch by itself, it will list all the branches in your repository, highlighting the current branch you are on. Create a new branch. You can create a new branch using git branch. Delete a branch. To delete a branch that is no longer needed, you can use git branch -d and give the branch name. So why it is important? Branches allows you to work on different features or fixes without affecting the main project. The git branch command gives you control over your branches, whether you are creating new ones, listing the existing ones, or cleaning up old branches. Now let's talk about the git merge command. So this command is essential when you want to combine changes from one branch into other, allowing you to bring together different pieces of works in your repository. The git merge command is used to merge changes from one branch into your current branch. So this is typically used when you want to bring in changes from a feature branch or any other branch into your main branch. Welcome to the Git branching and the merging session. Today we will explore branching and merging in Git, the two powerful features that allows you to work on different parts of a project simultaneously and then bring everything together when it is ready. Branching in Git. In Git, the default branch is called master or main in your repository. Branching is always a way to split off from the main branch or any other branch to work on a separate task without affecting the original code. For example, you can create a feature branch to work on a new feature or a bug fix branch to fix issues, all while keeping the main branch stable. Merging in Git. Once you have finished working on your feature or bug fix in a separate branch, you will want to merge that branch back into the main branch or another branch. This is where the git merge command comes in. Merging brings changes from one branch into other. You will typically merge your feature or fix back into the main branch or master. So resolving the merge conflicts. When the conflict occurs, Git will show which files are in conflict. You will need to open the conflicted files, decide which changes to keep, and remove the conflict markers. After resolving conflicts, stage the resolved files with git add and then complete the merge by committing them. That's a quick overview of branching and merging in Git. So welcome to the best practices for using Git. Using Git effectively not only keeps your code organized but also ensures smooth collaboration with teammates. Here are some best practices that will help you work more efficiently and avoid common pitfalls. That is commit often. So why it is important? Frequent commits help maintain a clear history of changes and allows you to roll back to the earlier state more easily if something goes wrong. Best practice is to commit your changes after completing a logical chunk of work such as adding a small feature or fixing a bug. It's better to have multiple smaller commits than a single larger one. Write clear commit message. Why it is important? Descriptive commit message make it easier to understand the history of the project. They help team members and the future you quickly grasp the purpose of each change. So the best practice is to write short but clear and meaningful commit messages. Focus on explaining why the change was made, not just what was changed. Start with a brief summary such as 50 to 72 characters. Use branches. So why it is important? Working directly on the main or the master branch can lead to messy or unstable code. Branches allows you to work on new feature, fixes or experiment without affecting the main project. The best practice is to create a new branch for each task or feature you are working on. This keeps your main branch clean and stable, and it also makes it easier to collaborate. If necessary, add a detailed description after a blank line. Pull before pushing. Why it is important? If other developers have made changes to the remote repository, pulling before pushing your own changes ensure that you are working with most up-to-date code. The best practice is that before you push your changes to the remote repository, always run git pull to merge the latest changes from the remote into your local branch. This prevents conflict and keeps everyone in sync. Use git ignore file. Why it is important? There are certain files, example the log files, temporary files, compiled binary, that don't need to be tracked in Git. Tracking these files can clutter your repository and make it harder to manage. So the best practice is to use a .git ignore file to specify which files or directories should be ignored by Git. This keeps your repository clean and focused on the necessary files. So that's about Git and best practices. Now let's move to the question and answer session.
Yeah, hi Veena. Kopla here. Can you
Yeah,
hear
hi
me?
Kogila. Yeah, yes, I can hear you.
Yeah. How do you undo the last commit in Git?
So in order to undo the last commit, you can use the reset keyword. So there is, you can use the soft or the hard keyword. So soft will do the last, undo the last commit while keeping the changes, whereas this hard will do the last commit and discard the changes.
Okay, thank you.
Thank you.
Hi Vina, myself Animesh. Uh, can you tell me the difference between Git status and Git diff?
Yeah, hi Animesh. So the Git diff will show the changes between the commits or the branches or the working directory. Whereas the Git status will display the status, the current status of the working directory and the staging area.
Okay, thank you.
Thank you.
Hi, Veena. I'm Rose. Can you explain that significance of that README file in Git?
Yeah, so the README file will give you the information about, means it is like an introductory file which will give you all the information about the usage, purpose, what are all the operations, then installation steps, everything you can find in that particular README file.
Thank you.
Thank you.
Hi, Veena. This is Bhavya here. So, how do you undo changes in the working directory?
Yeah, hi Bhavya. In order to undo the changes in the working directory, you can make use of a Git command known as checkout. So you can apply it as Git checkout hyphen file underscore. You can give the file name.
Okay.
Thank you.
Hi Veena, this is Aditi.
Yeah, Didi.
How do you delete a branch in Git?
So in order to delete a branch in Git, you can use a Git command that is Git branch minus D, give the branch name. So this command is to delete a local branch. So if you want to delete a remote branch, then you can make use of the command git push origin minus delete branch name.
Okay, thank you.
Thank you.
Hi Veena, Sandhya here. What is Git config used for?
Yeah, hi Sandhya. So Git config is mainly used for the configuration purpose, such as you can configure your name and the email. So sometimes when we push the details into the repository, it will ask for the authentication. So for that purpose, you can use this git config minus global, give your username as well as git config minus global. You can give your email as well. So this will authenticate you and you can push your contents into the repository.
Yeah, okay, thank you, Veena.
Thank you.
Yeah, hi Veena.
Yeah,
Uh,
hi.
Thank you so much for this amazing webinar on Git. And I thank everyone for all joining us today. We hope like everyone found the session insightful, and we appreciate your time and participation. Before closing the webinar, anyone wants to ask any questions, please feel free to ask.
Yeah, hi Veena, I'm Anubhav.
Yeah, hi, Anubhav.
Yeah, I'm asking that how would you handle a scenario where two developers are working on the same line of code and both pushing their changes to the same file, means at same instance they are doing. Then what step would you take to resolve that conflict? Basically, I'm asking a question regarding merge conflict.
Yeah,
Means
I
how
got
would
it.
you,
So the merge conflict, in that case, you will have to open the file. So already the Git will produce the error. So you will have to open the file and you have to remove the markers. So there will be conflict markers will be there. So remove that from the file and then decide which change that you have to keep, that the up-to-date code. Then keep it and then add it to the staging area, then commit it.
that marker is nothing but a green color kind of thing, I think.
Yeah, yes.
Okay. Yeah, thank you all. Thank you everyone for joining. That's all for today. Have a great day.